So I'm going to do the next 30 minutes of my talk before handing it over to Paul is I'm going to talk about a recent research project from this year that I've been working on with Rob Engel, Stefano Giglio, Brian Kelly, and Hebam Lee. And the observation that sort of motivated this project is that in many settings, a primary function of financial markets is really to allow for risk sharing across different agents. And so when you think about climate risk, what our question then was, well, how might you use financial markets to hedge against the realizations of climate risk? How do you share that risk? How do you make sure the person, that's best able to bear that risk does, so that, the price of the risk declines? And so, this is a problem that, we think about very frequently with a lot of other risks. And so we thought, well, let's think about this in the context of climate risk. And so in order to think about constructing this hedge portfolio, right, what you're looking for is a portfolio that pays off in states with particularly bad climate economic outcomes, right? So sometimes you think, for example, that there is that climate change, the physical process of climate change has tipping points. What you want to do is you want to think of a portfolio that does very, very well when you reach one of these tipping points, because those, are the states that you want to hedge against. And so that kind of then leads a bunch of important questions, that you have to address in order to do that. And, we make some progress in this paper, and some of the other presenters today also make progress on these. How do you identify these states? So what are the states of the world that you truly want to hedge against? Is this just based on temperatures? Is this based on, things like hurricanes, climate, is this about monetary damages from climate change, etc.? So you want to kind of be very careful about, when you think about a financial asset that you're trying to buy, think about if you were going to write an insurance contract, right? What would you write that insurance contract again, right? The outcome has to be very, very clearly defined. So what is that? What horizon? Right. So and here, I think some of the theory can be very helpful. Like, over what horizons is climate risk particularly problematic? And so those might be the horizons that you want to insure against. And then you want to think about, well, which assets payoffs correlate with these, right? So once you understand the states of the world that you want to insure against, you want to figure out which assets that, in some sense, do particularly well in those states of the world, or assets that do badly in those states of the world, and which you can then short in order, to create these hedge portfolios. And, quite often in financial markets, when you have a risk that you really care about insuring, what you do is you either go and write an insurance contract directly on that risk, or you can trade sort of derivatives that are directly linked to that specific outcome. And financial markets have made some progress in creating financial instruments that have payoffs that are relatively closely linked to the types of outcomes you might care about. So for example, there is derivatives, weather derivatives, that are used by farmers a lot. But really most of these financial assets have maturities of 1, 2, 3 years, and there aren't really any long-run insurance contracts to write or long-run derivatives that you could trade to say insure against realizations of climate risk 30, 40 years into the future. And I think there's a bunch of good reasons for that. One of them is that, given the magnitude of the aggregate risk component here, counterparty risk is going to be really, really fundamental. So yes, you're going to pay an insurance company the next 30 years, every year an insurance premium. But then when the climate disaster comes, who guarantees that insurance company is still around to actually be able to pay out? Right. And so, and similar with the contract. Now you could think about posting collateral, et cetera, et cetera. Financial markets have ways of dealing with this, but for the very long run outcomes, or the medium to long run outcomes we're talking about here, those types of contracts just don't exist. Right. And so what that, basically leaves investors to do is try and construct these hedges themselves. And so what our approach does is, it takes a very old idea in finance, that is sometimes attributed to Bob Merton, where the idea is that when it's infeasible to directly hedge the long-run risks, right, it might be possible to replicate the infeasible risk with a dynamic strategy, right? And so the idea is that you form a sequence of short-lived portfolios that hedge news about the long-term outcome, right? So rather than holding a portfolio that only pays off once if the outcome occurs, that would be an insurance contract. What you do is every period you form a portfolio that does a little bit better when there's bad news about the climate, something that you might associate with a higher probability of the bad outcome occurring, right? And this might then replace the idealized but unfortunately infeasible long-dated buy and hold contract with an actively managed portfolio that pays up on the arrival of bad news. And the hope is that sort of, accumulating these sort of, payoffs on the bad arrival of news would replicate that hedge. And so again, what you need to do, you still have to answer these two questions. What news, right? So how do we determine incremental shocks to the probability of climate change, to establish this sort of long-lived climate change? And then, how do you identify portfolios that are best suited to hedge this use? So these are the types of problems, that we had to solve. Now, what's going to be our contribution in this paper is to, to bring together data and some econometrics to engineer these types of climate hedge solutions. I want to be upfront about this, that I don't think and we don't view the sort of final portfolios that we construct in this paper as like the definitive ultimate climate hedge. We really think about this as a proof of concept of how you can use sort of relatively well-established tools within financial economics, take it to a very new problem like climate risk, and really kind of use that to help us better better sort of understand sort of the processes. And there's going to be lots of improvements you can make on both of these questions: what use, which assets. Again, so it's not really about providing a definitive climate hedge, but it's really about providing a proof of concept that these tools from financial economics are extremely useful in terms of thinking about these questions. Okay, so let's talk a little bit about what we do in the first objective: what news, right? So what you really want to do is you want to identify news about climate change, and those should be relevant to and salient for investors and hedgers concerned about climate risk. Now, there's lots of things that you could think about doing here, right? So you could think about traded prices, but in some sense, it's a little circular if you're then going to try and find assets that pay off in these states of the world. You think about weather data, right? So you could imagine, when it's very, very hot, when there's a heat wave, use that as bad news about climate change. You could think about disaster events, etc. What we do is, we extract news shocks from text provided by media outlets. And so what we're going to do is we're going to do two complementary approaches. And again, neither of them are perfect, and it really is a proof of concept. So the first one is we're going to look at the textual coverage in the Wall Street Journal, and I'll give you a little bit more detail in a bit. But basically, what we're going to do is we're going to look at a bunch of words that relate to climate change. We're going to construct a climate change vocabulary or climate change dictionary, and then what we're going to do is we're going to basically every day explore, every month or whatever, we're going to explore the fraction, more heuristically, the fraction of text in the Wall Street Journal that's dedicated to climate risk, right? And sort of using that approach, the implicit assumption is that when climate is talked about in the newspaper, it's usually bad news about the climate, right? And so what we're going to do is we're going to say, I'll show you this in a bit. We're going to say that when the Wall Street Journal writes a lot about climate change, again, that's bad news about the climate. And what we then look is, trying to form portfolios that do particularly well in those periods when there's lots of coverage about climate change in the Wall Street Journal. So that's one approach that you can take. The other approach that you can take, and is that you try and directly sign the sentiment of the different articles, right? And so, Zach will teach us a bit more about sentiment analysis in a bit. But basically, rather than say, when the Wall Street Journal writes about climate risk, it's bad news, you can actually try and sort of, sign the direction and try and say this is actually a positive article versus a negative article. So we work with a company called Crimson Hexagon that, is sort of a leader in social media and newspaper sentiment analysis. Sometimes we outsource the problem to someone else here. We construct a second index we're going to call the negative climate change news index. Now, again, what's really important here is that there's many, many, many degrees of freedom here, right? There's degrees of freedom in say for the first one, in the construction of the vocabulary. There's degree of freedom in which newspaper you look at. There's degrees of freedoms in how to measure sentiment, etc. So what we'll try and do, and in the paper we're very upfront about this, we try and constrain ourselves to the obvious choices. And actually, one interesting thing, for the this, because I think it's a PhD class, so sometimes for the history of the paper, there's value in that for the PhD students. So this paper was written for a sort of a special initiative that the RFS, the Review of Financial Studies, had about 2 years ago, where they asked for what they called pre-registered proposals, right? So the idea of pre-registered proposals is that you wouldn't submit a full paper, but what you would do is you would submit a plan about what it is that you would do in your final paper, and then you would get referee reports on that, and then the editor would say, look, if you actually execute what you say you will execute in this paper, we will publish the final paper independent of what you find, right? And the motivation here was, and I think this this comes back a little bit to my introduction, the motivation for the editors was they realized that climate finance was really a topic that the journal should be publishing more about. But one of the issues they had was that they weren't getting enough papers. And one of the reasons they thought they weren't getting enough papers is because there's risk involved in writing these papers, right? You can spend a lot of time, and then if you don't find anything, we all know how difficult it sometimes is to publish null results, right? And so they said, look, let's take that risk off the table to people. If people come with a good idea, we will promise to publish even if it's a null result. For our specific project, what that meant is that while there are many, many degrees of freedom, we kind of had to constrain our hands on the different choices we make for each of these degrees of freedom up front. And then kind of just see what happens down the end. And so that's another reason why, in some sense, if you kind of played around with this more than we did, rather than stick to this pre-approval plan, but kind of really kind of try and play around with, you could probably do even better. One thing I want to point out is these climate news series are on my website to download. So if you want to work with them, say if you want to construct hedge portfolios yourselves, and you want to tie your own hands and take someone else's climate news series, you can download those. A little bit more detail. So what's the vocabulary? So basically what we did is we looked at a lot of climate change white papers and climate change glossaries, from sort of authoritative bodies like the IPCC or the EPA and so on. And so it gives you a sense, what the types of topics are that we'd be looking for in the Wall Street Journal. So, climate, greenhouse emission, atmosphere, etc. And then again, what this measure does is, so formally what we do is, we create a word vector of this climate dictionary, and then a word vector for, the words used in the Wall Street Journal, and we look at what's called the cosine similarity between these two word vectors. Heuristically, really, again, the way that what we're doing is we're describing the fraction, the share of all the newspaper coverage in the Wall Street Journal that's dedicated to climate change topics on a given day. And so this is the level measure of this climate news shock series. And what you can see is that, during sort of salient events like, climate conferences, etc., this index spikes up, right? Now, this is a level series. So, what we'll want to do is, in the paper is we'll want to hedge innovations in this index. And so what we're going to do very simply is take AR1 innovations in this index. The other thing we do, I highlighted this already, is this, crimson hexagon, index, which basically, measures the fraction of news articles about climate change topics with a negative sentiment on each day. And if you look at the sort of the correlation between the two different indices, what you see is that they're actually quite positively correlated. So this assumption that when, the Wall Street Journal covers climate change a lot, this is on average a bad period about the climate, that's actually seems to line up with the sentiment measure. But there's a few idiosyncratic instances. So one thing, for example, you see here is that there was this period when the Wall Street Journal index spiked up, but no one else did. And this was a period when the Wall Street Journal was very aggressively covering what was the ClimateGate conspiracy, which was basically, in 2010, some worry that the conservatives and conservative media had that sort of climate scientists were sort of conspiring to make climate change look worse than it actually is. So, this was something that only the Wall Street Journal covered, hence a lot of climate words, but it didn't really show up in the other index. Okay, so then you have these indices, and basically, again, the idea is what you want to do is you want to build portfolios that maximally hedge sort of innovations to this climate news series. And so the problem is that, this climate news series, it doesn't really exist for a very long period of time. And again, climate risk has at best been priced in financial markets maybe for 20 years. So sometimes you have more assets you could possibly put on the right-hand side than you have periods in which you see realizations. And so you very naturally have a lot of overfitting problem here. And so what our solution was to this, overfitting problem, an in-sample overfitting problem, is to impose a bunch of structure on the estimation technique, on the estimation to confront the limited time series. But that still allows us to use a large number of assets to price it. And so what we're going to do is we're going to emphasize the out-of-sample performance, of our estimates. So really what we're trying to do is we'll try and see, only using information that you would have had in real time to construct these portfolios, to give it a fair shot, and also talk a little bit about the interpretability of the portfolio. Right. So here's the simple asset pricing model that we would define. And basically what you do is you put in a climate change factor. Again, that's defined as the AR1 innovation in the news index, and you put in a lot of other, could be tradable, could be non-tradable risk factors. So this is very similar to the standard asset pricing models we write down, except that we now have an additional risk factor, which is climate change. So how do we estimate this? What we're going to do is we're going to we want to create a portfolio that has a unit exposure to the climate change shock and a zero exposure to all the other factors. And so I'm going to use a very, very standard mimicking portfolio regression techniques. And basically what it is, we're going to put the climate series on the left-hand side, and we basically want to have a set of, we want to construct portfolios that optimally mimic the movement of changes in climate news over time. And so the way we're going to do that is we're going to, obviously, again, because the problem is we have more assets than we have time period. So even in sample, you could fit this perfectly and overfit this perfectly, but that's not the objective, because that's going to do terrible in your out of sample fitting. So instead, what we're going to do is we're going to look at firm characteristics. And so what we're going to do is we're going to form portfolios that sort firms on some characteristics, some measures of the exposure of firms to climate risk. And so, we're going to sort them on the standard characteristics of size, book to market, etc. But then we're also going to sort them on environmental characteristics. And what we use in this paper here, again, just as a proof of concept, is use two different E-score measures from two providers, MSCI and Sustainalytics. This is exactly where, some of the measures that Zach and his team are producing right now, you could fit that in here and you could rank firms based on that rather than what we did. And it might work better, it might work worse. Again, this is something, here's the proof of concept, that we're doing here. And then what you're going to do is you're going to regress realizations of news series on sort of, these sorted portfolios. And what that will allow you to do is allow you to figure out sort of what weights on these different portfolios optimally allow you to mimic the out of sample realizations of climate news. So, if you kind of want to get into the details of the asset pricing model, it's very well described in the paper. I think, for the purposes of today's talk, really getting the heuristic understanding is the most important one. I just want to talk a little bit more about sort of these climate exposure measures that we use. So the MSCI measure is basically a measure that aggregates 23 different environmental assessment criteria, things like carbon emission, energy efficiency, etc. What's really problematic, I think, for all of us is these are extreme black boxes. No one really knows what goes into any of these measures. And what's actually even worse is that there is almost no time series stability in these measures, right? So these measures are designed to, at any given point in time, cross-sectionally rank firms, but the models change over time. And so what you can't do is use a model from the past, when so the numbers move around, it's very, very hard to form your out of sample forecast. And so what we're going to use is we're going to, in addition to the absolute measures, we're also going to use cross-sectionally ranked measures. And again, I just wanted to point out that there's many, many more measures of firm level risk exposure that are being produced. And, time will tell which of these are sort of the best ones to allow us to optimally form these hedge portfolios. So how does the thing that we do work? Basically, let's figure this out. Basically, what this regression here is showing, it's putting innovations to the Wall Street Journal Climate Change News Index on the left-hand side. And what it says is that, these portfolios ranked either by Sustainalytics or by MSCI, e-scores actually load onto this realization. So what does this mean? It means in periods when there's negative news about climate change, portfolios that go long, high e-score firms and short low e-score firms, either go long, climate positive firms and go short climate negative firms, those portfolios outperform. And that's both true if you use absolute and relative ranking, and it's true if you use the Sustainalytics and the MSCI measure. Statistical power is a bunch stronger when using the Sustainalytics measure relative to the MSCI measure. The R squared is also much higher when you use the Sustainalytics score than the MSCI score. So that suggests that the e-scores as provided by Sustainalytics do a better job at capturing this climate exposure than the scores provided by MSCI. One interesting comparison we just had at the end is, we said, well, what would have been something naive that you could do? Well, one thing you could have said is you try and construct a portfolio that's the market, but you go short XLE, which is basically an ETF trading the carbohydrate firms, and you go long PBD, which is an ETF trading renewable energy firms. And so basically you can think that would have been another hedge portfolio you might have thought. Just basically go short oil and long renewable energy and see how that portfolio does in terms of hedging this climate news. And what column 5 shows you is that actually this sort of e-score ranked portfolio does much, much better at hedging the climate news series than just a simple industry tilt away from, carbohydrates and towards renewables. We don't fully know why that's the case, but I think, it sort of shows the value of sort of the more systematic approach that we're taking relative to sort of something simple that you might have done instead. Okay, so this is the in-sample regression. How does this do out of sample? So again, what you can see here is that even out of sample, we are getting relatively decent hedges for the Sustainalytics. We're getting basically zero hedging power for the MSCI one. That's consistent with MSCI was already weaker in sample than it was, than Sustainalytics. And out of sample, MSCI is essentially giving you no hedging whatsoever. You're getting much better out of sample hedges with the Sustainalytics scores. Now, these correlations are actually pretty high. So it's a correlation table relative to, when we think about financial market returns, it's actually very hard to explain returns with anything. So, the correlation that's sort of implicit in this top left panel, where you can see on the left-hand side, the innovation on the horizontal axis, the innovation in the index, and on the vertical axis, the out of sample hedge portfolio return. The fact that, when the index goes up and there's more bad news about the climate, the hedge portfolio does relatively better. This slope here might seem bad, but as far as asset pricing goes, this is a pretty good correlation in terms of generating hedges. Okay, so what's the conclusion here? So again, what do we do in this paper? We propose an approach for protecting investor portfolios against adverse effects of climate change. There's lots and lots of obstacles to practical implementations of these climate hedge solutions, right? So what do we do in this paper? So we navigate this by taking, rather than trying to hedge a long-term faraway outcome, we're taking short-term dynamic perspective on this fundamentally long-lived risk. We identify shocks or news about the long-lived effects by measuring this news in, either the Wall Street Journal or, the sentiment analysis part. We think the results are very, very promising. So you get pretty stable out of sample hedges that the stability is basically because, we have this extremely parsimonious statistical model where we rank firms only on this one characteristics, either Sustainalytics score or the MSCI score. You could imagine forming these hedge portfolios on more than one characteristic, right? So you might imagine taking, a physical risk measure as well. So, one interpretation of this E score that I gave before is that it primarily captures transition risk, right? And it doesn't really capture physical risk very well. So you might think about ranking both on physical risk score and on regulatory risk score, just as one example. And, again, we were kind of, tying our hands a little bit because we wanted to exploit third-party measures of the climate sensitivity. But, as you'll see in the, presentation after the next one, you can actually construct these yourselves. What's really, there's many unexplored degrees of freedom here, right? How to measure climate news, what ESCOs to take, what hedge assets to use, right? So one of the things we did in this specific project is we restricted ourselves just to traded US equities. In part because if you need to use E-scores to rank them, the sets of assets that are ranked by, Sustainalytics or MSCI or, any other data providers is relatively limited. But, given some of the discussions we had earlier, there might actually be other assets and other asset classes that might be much more exposed to climate risk and might therefore provide much better hedges. Think about real estate, think about, we'll hear from Paul if municipal debt might be one of them, et cetera. So, there's a lot of potential improvements, also on the scope of the assets that you include, in the various hedges. And so I think, that this area really provides, a lot of exciting opportunities for follow-on work, for PhD students, really taking each one of these three dimensions, trying to improve upon them, trying to sort of, use that to improve our understanding, both of how, climate risk is already priced in financial markets, and then also, how you can, as a result, use financial markets to hedge your own exposure against climate risk, in particular in the absence of, financial assets that do that directly. Now, my prediction is that we'll see a huge amount of financial innovation in this space over the next 10 years, right? So if you think back to the Larry Fink letter, right, this huge concern that essentially every financial market participant has about this type of risk means that the demand for for assets that hedge this risk is very big. So I would well imagine that these types of hedge portfolios, which we're forming sort of, in an ad hoc basis here, might become traded ETFs, or, or that in the derivative side, you might get innovation there on actual derivatives on realizations of climate risk down the road. So people, get better at defining what the events are. They get better at collateralizing the underlying asset to make sure, that there's little counterparty risk, etc. So I think, in addition to sort of using these, ad hoc approaches like here, I suspect we'll see, a lot of financial innovation in this space over the next few years. And again, whenever there's financial innovation, there's scope for research to help guide that financial innovation and to to talk about how to optimally design derivatives contracts, for example, and so on.